Hello friends, welcome to EC Academy. In this video, let us understand the CMOS fabrication process. Now let us understand the basics first. We know that CMOS is a technology that uses N channel, which is nMOS, and P channel, which is pMOS. And nMOS and pMOS are built together. To build both nMOS and pMOS together, we need a single base. So in NVEL process, the base will be P-type silicon substrate. Now since the base is already P-type, we can directly build our nMOS transistor on it. But where will we build the pMOS transistor? To build the pMOS transistor, we need N-type base. So to solve this, we'll dig a pool or a well inside a P-type and we'll fill the N-type material inside it. This pool is known as N-well. This method is most commonly used technique today because it is very compatible with older nMOS manufacturing method. Now let us go through different steps that are used in N-well CMOS fabrication process. The first step is substrate preparation, which is nothing but establishing the foundation. First, we take a P-type silicon piece that will be used as our base. Then we grow a thin layer of oxide on the top of it. So why do we do this? It is just like putting a screen guard on your mobile phone. So this oxidation layer is to protect the P-type substrate. The second step is N-well formation. In that, first we'll perform selective phosphorus implantation. So in this step, we need to make an N-well pool. So we'll use an N-mask, just like a stencil, to decide exactly where the N-well will be formed. Then we'll implant phosphorus into the silicon. And this phosphorus is an N-type material, which is known as a dopant. After putting the phosphorus, the next process in second step is we heat it up to a very high temperature so that the N-well will become very deep and it is formed uniformly. The third step is active area definition. An active area is simply the place where our actual transistor will sit. We look at the area that is meant for our transistor and will remove the protective field oxide from those exact spot. And also we adjust the thickness of the oxide to keep the devices isolated or separated from each other. The fourth step is threshold voltage adjustment. Every transistor needs a specific voltage to turn on, and this voltage is known as threshold voltage. To adjust this turn on voltage or threshold voltage, we do a very light P-type doping so that we can set the threshold voltage of the transistor. The fifth step is polysilicon gate formation. Every transistor is having a gate that controls the electricity flow. To make this, we first grow a thin oxide layer which acts as a gate oxide. On the top of that, we deposit a material which is called as polysilicon. Then we cut a pattern to this polysilicon to form the actual gate of the transistors. The sixth step is source and drain formation. A transistor needs a source where electricity enters and drain where electricity leaves the transistor. For N-channel transistor, we put a chemical known as arsenic, which is N-type, and for a P-channel transistor, we put a chemical known as boron, which is P-type. You need to remember that the arsenic is used for N-channel and boron is used for P-channel. The last step is contact and metallization, where we'll do the interconnection. Now our transistors are ready, but we need to connect them. So we'll make a small holes which are known as contact openings to expose the terminal, and finally we deposit the aluminum pattern to create the interconnections. This aluminum will act exactly like electrical wiring. So this is the final architecture of N-well CMOS transistor, where this region represents pMOS transistor and this region represent nMOS transistor. Here, this pMOS transistor will be isolated with this nMOS transistor with the help of this N-well. This N-well will act as isolation or protection between this pMOS transistor and nMOS transistor. So, N-type material will be present in a P-type substrate and P-type material will be present in N-well, and these two are isolated. So before we conclude, let us understand the key characteristics of pMOS and nMOS. The pMOS transistor are isolated within the N-well pool, which means they do not interact with P substrate. So this will help in better noise immunity, but the pMOS transistor is affected by something called as body effect. So while designing, we need to be careful to avoid this effect. The nMOS transistor are directly built on P-type substrate. As you can see in this diagram, they are directly built on P-type substrate. Because of this, the electron which are present in them will move very freely, which is known as high electron mobility, which will make nMOS transistor to switch faster. One of the drawbacks of N transistor is it is highly susceptible to parasitic substrate noise. So finally, let us quickly revise what we have learned today. The N-well process allows us to build both nMOS and pMOS on P-type substrate. There are 7 steps. First step is substrate preparation, where we'll use P-type base. Second step is N-well formation, which we call it as phosphorus pool. Then active area definition. Then the threshold voltage will be adjusted. Then polysilicon gate is formed. Then source and drain formation is done using arsenic and boron. Finally, the contact and metallization is done using aluminum wiring. This is about N-well CMOS fabrication process. Hope you have understood the topic. Thank you.